Hi, and welcome back to our channel Neurabytes. My name is Navjinder Virdee, and in this lesson we will go through another interview coding question for linked list. Our second interview coding question is to check whether the linked list is palindrome or not. This question has been asked in various tech companies such as Microsoft, Amazon, Snapdeal, and many more. So, first let's understand our problem statement. We will be given a linked list and our task is to check whether the linked list is palindrome or not. The function should return true if the list is palindrome and false otherwise. First, what is a palindrome now? A palindrome can be a word, phrase, or sequence that reads the same backwards as forwards. For example, let's take a string ABA. From backwards, it is read as ABA, which is same as forward, so it is a palindrome. Let's take another string DEF. From backwards, it is read as FED, so it is not a palindrome. Next, let's take a list 11, 14, 15, 14, and 11. And from backwards 11, 14, 15, 14 and 11. So it reads the same as backwards as forwards. So it is a palindrome. Let's go through some examples in order to understand the problem better. So our first example is the following. The list is 1, 2 and 3. Let's check whether this list is palindrome or not. It will return false, because from backwards it is read as 3, 2 and 1, which is not the same as forwards. Let's go through another example. Let's say we are given the following list 10, 12 and 10. Let's check whether this list is palindrome or not. It will return true, because from backwards it is again read as 10, 12 and 10, which is same as forwards. Let's go through one last example. Let's say we are given only a single node 100. So this list is going to be palindrome because from backwards it is again 100, which is same as forwards. Now let's learn how to solve this problem. If you would like to think of a solution, then stop this video right now. Suppose we are given the following linked list. Our first step is to find the length of the linked list. So for the above list, the length is going to be equal to 4, because the above list contains 4 nodes 10, 20, 20 and 10. Then the second step is to break the list from the middle into 2 halves. Now there can be 2 cases. Case 1 is when the length is even. The list will be broken into 2 equal halves. For example, if the length is 6, then the list will contain 3 nodes. If the length is 8, then the 2 lists will contain 4 nodes. And if the length is n, then the 2 lists will contain n by 2 and n by 2 nodes. Case 2 is when the length is odd. In this case, one list will contain 1 extra node. So if the length is 5, then the first half will contain 3 nodes and the second half will contain 2 nodes. If the length is 7, let's say, then the first half will contain 4 nodes and the second half will contain 3 nodes. If the length is n, then the first half will contain n by 2 plus 1 nodes and the second half will contain n by 2 nodes. The division here is integer division. So now let's break the list into 2 halves. So the above list will be broken into, the first half will be 10 and 20 and the second half will contain 20 and 10. Now in order for the list to be palindrome, the last node's data should be equal to the first node's data, and the second and third node's data should also be equal. So in order to compare these data values easily, we will reverse the second half of the list. we learned about how to reverse the list in the previous lesson. So if you haven't seen the last lesson, please check it out. I have provided the links in the description below. So now we have reversed the second half of the list. The next step is to compare the data of the corresponding nodes of both the halves. First, 10 will be compared to 10 and then we will compare 20 with 20. Since they are same, so the list is a palindrome. So we have got our result, which is true in this case. Now, the next step is to reverse the second half of the list again. We have reversed the second half again and it is again 20 and 10. Now, the final step is to join both the halves to form the original list again. Now we will join both the halves and we have got our result, which is the list above is palindrome. Now let's go through one full example. Suppose we are given the following linked list. Our first step is to find the length of the list. We will create a temporary reference and assign head to it. Now both the temporary reference and the head point to the first node, that is 1. Then we will create a length variable and assign 0 to it. Then we will traverse the list using the temporary reference, and on each iteration we will keep on incrementing the length variable while moving one node forward until we reach the end of the list. So initially our length is 0 and temporary is pointing to 1, which is not equal to none, so we will increment the length and move one node forward. Now length becomes 1 and temp is pointing to 2, which is not equal to none, therefore we will increment the length and move one node forward. Now length becomes 2 and temp is pointing to 3, which is not equal to none, therefore we will increment the length and move one step forward. Now length becomes 3 and temp is pointing to node 4, which is not equal to none, therefore we will increment the length and move one node forward. Now length becomes 4 and temp is pointing to 1, which is not equal to none, therefore we will increment the length and move one node forward. Now length becomes 5 and temp is pointing to none, so we have got our length now and we can stop. Our length is 5. The second step is to break the list into two halves from the middle. The indexes shown below the list are for the sake of understanding only. First, we will calculate the mid of the list using the length variable that we calculated in step 1. If the length is even, then mid is length by 2, else the mid is length by 2 plus 1. Then we will create a variable I and assign 0 to it. Now the first half should contain nodes with indexes 0, 1 and 2, and the second half should contain nodes with indexes 3 and 4. So we will traverse the list using when I is less than mid minus 1, we will keep on incrementing the variable I while moving to the next node using the temporary reference. So we have to reach the node at index 2 in order to break the list into two halves. So using temp is equal to temp.next, we will move forward while incrementing I. Initially I is equal to 0, mid is 3 for this case, and mid minus 1 is 2. Since I is less than mid minus 1, therefore we will move forward and increment I. Now I becomes 1, which is again less than mid minus 1, therefore we will move one node forward while incrementing I. Now I becomes 2, which is not less than mid minus 1, therefore we will stop the while loop here. Now we have reached the node at index 2, so the next step is to create a head to reference and assign temp.next to it, that is node at index 3. And then we will break the list by changing temp.next is equal to none. So now we have broken the list into two halves. Now the next step is to reverse the second half of the list. So the first half is 1, 2 and 3 and the second half is 2 and 1. We will reverse the second half. Now the second half is reversed with nodes 1 and 2. Next step is to compare the data of the corresponding nodes of both the halves. So 1 will be compared to 1, which is same, and then 2 will be compared to 2, which is also same. Since they are same, so we can say the list is palindrome. Now, the next step is to reverse the second half of the list again. So, initially with 1 and 2, it will be reversed to form 2 and 1. And the final step is to join both the halves again. We will traverse the first half of the list to get to its last node, that is node at index 2. Then we will change the next pointer to point to the node at index 3 using the head to reference. We will look at that while we implement the code. Let's implement the code now. For this problem, we have to implement the following 6 steps. So the first step is to find the length of the list. First, we will create a temporary reference and assign head to it. Then we will create a length variable and assign 0 to it. And then we will traverse the list using the temporary reference, and on each iteration we will increment the length variable while moving to the next node using the temporary reference. And finally, in the end, we will return the length of the list. Now, the next step is to break the list from the middle into two halves. First, we will compute the mid of the list using length variable that we calculated in step 1. So the middle is length by 2 if length is even, else the mid is length by 2 plus 1 if the length is odd. Note that the division here is integer division. Then we will create I and assign 0 to it, and head will be assigned to 10. Next, we will traverse the list using I less than mid minus 1, and on each iteration we will move one node forward while increment the variable I. So when we have reached the mid of the list, we will break the list. Head 1 becomes the old head and head 2 becomes temp.next, and then temp.next becomes none. And we will return the tuple head 1 and head 2. The third step is to reverse the second half of the list. We have already implemented the reverse function in the previous lesson. So if you haven't seen the last lesson, please check it out. The fourth step is to compare the data of the corresponding nodes of both the halves. First, we will create two temporary references. temp1 is equal to head1 and temp2 is equal to head2. Then we will traverse the second half of the list until the end. And in each iteration, we will compare the corresponding nodes data. If the data is not equal, then the list is not a palindrome, and in this case we will return false. Otherwise, we will move one node forward in both the half of the list. And if we don't found unequal data, then we will return true. Now, the step 5 is to reverse the second half of the list again. We have already implemented the reverse function in the previous lesson, so we will move to step 6, which is to join both the halves to form the original list. We will create a temporary reference and assign head1 to it, and then we will traverse the first half of the list and get to its last node. After reaching the last node of the first half of the list, we will change its next pointer to point to the first node of the second half using head2. And finally, we will return head1 as the new head of the original list. Now let's implement the main function is palindrome. The first case is when the list is already empty or the list contains only a single node. Then in this case we will simply return true. The second case is when the list contains two nodes. Then we will check the data of the two nodes with each other. If they are equal, then the list is palindrome, otherwise it is not. Now, the third case is when the list contains more than two nodes. So we will perform the following 6 steps. First, we will find the length of the list. Step 2 is to break the list into two halves from the middle. Then the third step is to reverse the second half of the list. The fourth step is to compare the data of the corresponding nodes of both the halves. And the fifth step is to reverse the second half of the list again. And finally, we will join both the lists together to form the original list. And we will return the result whether the list is palindrome or not. So let's check it out. Let's say we are given the following list with nodes 1, 2, 3 and 4. Let's check whether this list is palindrome or not. So the list 1, 2, 3, 4 is not a palindrome. Now let's check whether the following list with nodes 10, 12 and 10 is a palindrome or not. So the list with 10, 12 and 10 is a palindrome. Next, let's check out a single node list. So it is obviously going to be a palindrome. Now let's check a bigger list with nodes 100, 200, 100, 200 and 100. It is a palindrome because it reads the same backwards as forwards. And one final test is to check the following list with nodes 10, 100, 10, 200 and 100, which is not a palindrome because it does not read the same backwards as forwards. Now let's go through the time complexity for this problem. The time complexity of find_length function is linear in terms of the length of the list, where n is the number of nodes in the list. This is because we have to go through each node of the list individually and increment the length variable. The time complexity of break the list is big O of n by 2, which is again linear in terms of the length of the list. This is because we have to traverse half of the list to get to the middle node and then break the list. The time complexity of reverse function is big O of n by 2, which is again linear in terms of the length of the list. This is because we have to go through each node of the second half individually and then change the pointers. So the total time complexity is also linear. Big O of n for find length, big O of n by 2 for break the list, big O of n by 2 for reverse the second half, big O of n by 2 to compare the two halves, big O of n by 2 to reverse the second half again, and big O of n by 2 for joining the two halves. Thank you for watching. In the next lesson, we will go through one more coding question and then we will start with another data structure. If you liked the video, then please like, subscribe and share. And I'll see you in the next lesson.